Okay, so for our last example in this section, let's do a projectile motion problem. So, example 4. You launch a rocket directly upward from the ground with an initial velocity of 112 feet per second. Let's determine the position function for the rocket. So, since we know in this case the initial velocity was measured in feet per second, then that tells us we're going to use the position function s of t is equal to negative 16 t squared plus v sub 0 t plus s sub 0, where here t is time in seconds, v sub 0 is the initial velocity, s sub 0 is the initial position. So then directly substituting into this formula, so our initial velocity we know is 112 feet per second, so s of t is going to equal to negative 16t squared plus 112t, so that's our v sub 0 or our initial velocity, plus now we got to figure out what the initial height was. So in this case, we're launching the rocket directly upward from the ground. So because we know the ground, we know s sub 0 is going to equal to 0. So plus 0. And then just simplifying that because adding 0 is the rest of the stuff. So it's just negative 16t squared plus 112t. Now that we know what the position function is, let's determine the average velocity of the rocket from 1 to 3 seconds. So to find average velocity, remember average velocity, you're talking about 2 points in time. And so in this case, we need to figure out, okay, what is the position at 3 seconds? So s of 3 seconds is going to be negative 16 times 3 squared plus 112t. So this is just finding, plus 112 times 3. And remember, this is just finding our y sub 2 and our y sub 1, or in this case, s of 3 and s of 1. But this is the same idea as finding your y2 and y sub 1 in the slope formula. So in this case, negative 16 times 3 squared plus 112 times 3. You do that math, you should get 192 feet. S of 1, same idea, negative 16 times 1 squared plus 112 times 1. So that's negative 16 plus 112, which is 96 feet. So we know y sub 2, y sub 1. So then, and our x sub 2, or in this case, our t sub 2 is going to be 3 seconds. And our t sub 1 is going to be 1 second. So now that we have the y coordinates, or in this case, our position at time 3 and position at time 1, now we want to find the average velocity. So remember, to find the average velocity, it's the exact same as finding the slope of any other line from algebra. So in this case, it's going to be s of 3 minus s of 1 over 3 minus 1. So in this case, s of 3 we know is 192 feet minus s of 1, which was 96 feet, divided by 3 seconds minus 1 second. Yes, you need to include your units. And so that gives us, in this case, 96 feet per 2 seconds, which then reduces and gives us 48 feet per second for the average velocity. So what this is saying, this is telling us that the rocket was ascending, and in this case we know ascending because the sign is positive. So the rocket was ascending an average of 48 feet per second over the interval from 1 second to 3 seconds. Now let's find the instantaneous velocity of the rocket at the point 3 seconds. So instantaneous velocity, remember, so velocity at time t is equal to the derivative of position. So in this case, our velocity is equal to the derivative of our negative 16t squared plus 112t. So the derivative of that is negative 32t plus 112. So that's our instantaneous velocity formula. So now we need to find the velocity at time 3 seconds. And so that gives us then negative 32 times 3 plus 112. And so that gives us 16 feet per second. So what this is telling us then, this is saying that the rocket is ascending, again, ascending because it's positive. It'd be descending if the velocity was negative. but the rocket is ascending at 16 feet per second whenever we're at the instant that time is 3 seconds. So at exactly 3 seconds, the rocket's going up 16 feet per second. Next, we want to know, when does the rocket hit the ground? So when the rocket hits the ground, we know that position, so S of t, is going to equal to 0. So we need to solve this equation for time t. So to do that, so S of t, remember, was negative 16t squared plus 112t. And we're going to set that equal to 0. So again, factor first, right? In this case, this factors very easily. We have a greatest common factor of negative 16t that we can factor out. And so we factor out negative 16t, and that leaves us with t minus 7 inside, equals 0. So then negative 16t equals 0. It gives us t equals 0. We already knew that when t is 0, it's going to be on the ground, right? Because it started on the ground. So we really don't care about that one. But then t minus 7 equals 0 gives us 7 seconds. So in this case, the rocket's hitting the ground at 7 seconds. So to find the velocity of the rocket when it hits the ground, well, that's just saying find v of 7 in this case. So we already know v of t, we found it earlier, was negative 32t plus 112. So then we're just finding v of 7. So that's negative 32 times 7 plus 112. And so in this case, that ends up giving us negative 112 feet per second. Or in other words, what this is saying, the rocket is falling 112 feet per second when it hits the ground.